The early days of planets forming are violent times, with asteroids, comets, and planetesimals smashing together and pelting into one another. This happened to the Earth and Moon, the other inner planets of the solar system, and is happening right now to newly forming planets around other stars. In an incredible historical milestone, the Hubble Space Telescope has just directly imaged similar high-energy collisions in a nearby planetary system around another star. The star in question is actually a fairly well-known one. I've even talked about it in videos before. It's called Folmalhaut, and it's probably so well known because in most images we have of it, it looks like the fiery Eye of Sauron. For the first time, astronomers have seen a point of light appear out of nowhere in a planetary system around a star beyond our solar system. It's not in previous Hubble images of Fomalhaut, meaning we witnessed the collision of two massive objects, creating a huge debris cloud that is now reflecting loads of light in our direction. This is unlike anything in our solar system today, but in the past it would have been very common. Alongside the release of this discovery, we got some fancy animations of what this could all look like in theory. But do remember that in reality, we just have static images from Hubble, showing a new point of light appearing around the star. So when I show you things like this, these are all animations and it's not the real Hubble data. Fomalhaut and its fancy planetary system is just 25 light years from Earth, and it's actually one of the brightest stars in the sky. It is easily visible with the naked eye, in the constellation of Pisces Austrinus, the southern fish. It's a brighter and more massive star than our Sun, and it's encircled by several belts of dusty debris, giving it the Eye of Sauron look. In 2008, Hubble discovered a candidate planet around Fomalhaut, marking the first system with a possible planet found with visible light. All others up to this point had been found with infrared light, or other light beyond what our eyes can see. The object doesn't look like much, just a bright spot in the dust belt, but it's definitely there. However, that candidate planet now appears to actually be a dust cloud, simply masquerading as a planet. That's because it faded over time in subsequent images. Something you don't expect a planet to do, but an expanding dust cloud would. You see, the images we have aren't good enough to image a planet in the same way we can image our solar system planets in so much detail. They're really just bright spots around stars, and dust clouds can look very similar. That object, which probably is a dust cloud, is called Fomalhaut b, or at least it was. By default, planets around other stars just get named after the star, but with lowercase letters after the name, starting with B and going through the alphabet. So this first one was Fomalhaut b. Any companion stars in the same system get named after the star too, but with uppercase letters after the name, starting with A. It's not too important here, and there isn't such a star in this system, but it's good to know. Anyway, when Hubble took recent observations of Fomalhaut, astronomers went looking to check in on Fomalhaut b. Much to their surprise though, they found a second point of light around the star, in actually a similar location. They named that object Circumstellar Source B, or CS2, and Fomalhaut b has now been rebranded as CS1. CS2 is thought to be a collision between two asteroids, or two tiny baby planets in the Fomalhaut system. These sorts of collisions would have been very common early on in the formation of our solar system, but they don't happen now. The young Earth and Moon, for example, were constantly bombarded by asteroids. You can still see most of those impacts on the Moon, and these probably were essential for forming life and the planet as it is now. The reason why CS1 and CS2 are physically so close together, though, is a mystery. If collisions between asteroids and planetesimals were truly random, CS1 and CS2 could appear pretty much anywhere around the star, so it's surprising, but maybe not shocking, that they're so close together. Another mystery is why we saw two similar events in such a short time frame. We previously thought that there should be collisions like this every 100,000 years or so, but around Fomalhaut we've seen two in 20 years. I say we've seen two. We saw CS1, which probably is the aftermath of a collision, and now we've seen CS2 forming. So we're counting that as seeing two, but we've only just seen one happen. Collisions are fundamental to the evolution of planetary systems, but they're rare and difficult to study. So it's actually really exciting that we've seen this new one. What we've seen can tell us interesting things about the size of the colliding objects, and lets us estimate how many of them there might be in this dusky debris disk around Fomalhaut. And this would have been impossible to do without this collision observation. The results give estimates of objects about 60 kilometers in diameter colliding in these impacts, and probably about 300 million such objects orbiting in the Fomalhaut system. Of course, this number might be a bit biased because we saw two in quick succession, and maybe that is the statistical fluke, but it's the best we can do for now. This also acts as a bit of a warning for future issues we might face. If we're going to be increasing and improving our efforts to directly image exoplanets and their systems in the coming years and decades, and that is something we'll be doing. For example, with NASA's next flagship telescope, the Habitable Worlds Observatory, in the 2040s. Then there could be many more cases of mistaking debris clouds and dusty impact residue for actual planets, so we'll need to be careful. Fomalhaut's CS2 looks like a planet-reflecting starlight, but it appeared out of nowhere. Again, something planets don't tend to do. If we'd only just taken an image of that system, we'd probably have thought this was a planet. And these clouds can masquerade as planets for many, many years before they change, dim, and dissipate. Excitingly, the team involved with this discovery have time with Hubble to monitor CS2 over the next 3 years. They'll get to see how it evolves, how it fades or gets brighter. Does it change in shape, and is its orbit consistent? Since the new cloud is closer to the main dust belt around Fomalhaut than the old CS1 cloud, it's more likely to encounter other material in the belt, which could lead to a sudden avalanche of more dust in the system, causing the whole area to get brighter. The team will also use the near-infrared camera on JWST to image the cloud, which could reveal the size of the dust grains and the exact composition of the cloud, and even determine if it contains water ice. An exciting time in astronomy continues, especially if you love asteroids smashing together and learning about dust. Okay, one of those things probably sounds cooler than the other, but in astronomy, both can be very important. Let me know your thoughts about all of this, and whether you're excited for humanity's first colliding asteroids caught on camera. You can check out other videos on the channel if you'd like to spend some more time together. And we have mugs and t-shirts for sale too, and you can leave any questions and comments you have down below. Thanks a lot for watching. Until next time, stay safe team. I'll see you soon. Bye!